Hello, and welcome to this short screencast on Apache Mahout, the scalable machine learning utility in the Hadoop environment. In this screencast, we'll see what is Apache Mahout, the motivation behind it, and short demo on the real-world application of Apache Mahout. First of all, we'll need to look at data analytics. Data analytics is nothing but gaining useful bits of information for large amount of data. Nowadays, the world is flooded with large amount of data, but not all of it is useful. We need to find important or useful information from this data that will help us in our decision making. So one of the way to do data analysis is machine learning. So machine learning, as given in the slide, is subset of artificial intelligence. It is a way of training the computer in such a way that it would be able to take decisions for itself without being explicitly told to do a particular thing. That is, it consists of algorithms that train themselves so that whenever a situation arises where the computer has to take a decision, it does so automatically. So there are various applications of machine learning in real world, that is healthcare, where you have a large amount of patient data and you find a particular pattern in the data of the patients which would help you to predict a particular disease in the future. Marketing personalization, that is many times it happens that when you search for a particular product on e-commerce sites but don't actually buy it, you find ads for that particular product on your other social networking sites. Online search, the classic example is Google. It monitors every click you do on a particular search query. That is, if you find a particular link helpful on the first page, it assumes that the algorithm worked correctly. Or if you don't click any link after a search query, it assumes that the algorithm didn't work correctly and it trains itself in that way. Another is the recommendation system. That is, whenever you buy two items together, it recommends that the third item should also be bought with this item. So that is another example of machine learning. So the problem that we face in the real world is this. There are various programming languages like R and Python which are very good at analyzing data, but they are only good at analyzing short amount of data. Whenever the data sets get very large, they are not efficient. But Hadoop was a framework that is given on the right side of the slide, which was designed to handle or manage large amount of data. The problem with Hadoop is that it is not very good at mining data. So we need some way so that we could perform this machine learning algorithm on this large amount of data sets or big data sets. So this is where Apache Mahout comes into the picture. It integrates the machine learning facility with the great framework for handling big data, that is Hadoop. So Apache Mahout, it's an Apache Software Foundation project. It creates scalable machine learning libraries. One of the advantages of Mahout is that it has an active community. That is, there are lots of people who are actually working on Mahout right now. So you can get your doubts answered very quickly. Many machine learning algorithms are very complicated. Don't have proper documentation and examples so that you cannot explore them on your own. But Apache Mahout is not like that. It has a great documentation and examples, and many machine learning algorithms which are in the real world right now, they lack scalability. That is, as mentioned earlier, work on small data sets but fail on large data sets. Or and the last reason why Mahout is very good is because it's real world. That is, it can be applied in the real world. Many machine learning algorithms theoretical, that is exist only on paper but cannot be applied on the real world. So goal one for Apache Mahout is obviously machine learning. That is, you need to incorporate as many machine learning algorithms or techniques. Then only it will be used by large amount of people, because if it doesn't have many machine learning algorithms, it won't be used. So as shown in the slide, Mahout contains many popular machine learning applications like genetic algorithms, classifications, clustering, recommenders, and so on. The goal 2 for Apache Mahout is scalability, which is the most important goal for Mahout because it has to work on large data sets. The machine learning algorithms will have to perform efficiently so that useful information will be provided to the decision makers at the right time. So it has to be scalable, it has to be fast and efficient. And this is because most of the Mahout implementations are developed using the MapReduce framework of Hadoop, which makes the processing of large amount of data sets very efficient. So currently Mahout contains 3C plus FPM plus O. Now we'll see what this 3C plus FPM plus O means. The 3 C's includes the first C, that is collaborative filtering. Collaborative filtering is an example of recommender system. That is, whenever you buy, that it recommends a particular user that which things he or she should buy. So there are two types of recommenders, that is the user based recommender and the item based recommenders. We'll see the difference between the user and item based recommenders now. Now there are suppose two users, that is Ameya and Sohan. Ameya buys three books, that is Hadoop Definitive Guide, Mahout in Action, and Hadoop in Action. He also gives them some particular rating. Sohan also buys four books, Hadoop Definitive Guide, Mahout Cookbook, Hadoop in Action, and Hadoop and Mahout. So Amaya and Sohan have brought two books which are common, that is Hadoop Definitive Guide and Hadoop in Action. So based on it, what user-based recommender will do is it will recommend Sohan the book Mahout in Action, as the two other books brought by Amaya and Sohan are common. So this is a user-based recommender. What item-based recommender is that it actually recommends a particular item to a user by scanning the entire item list. For that is, now as we can see, Amaya brought books Hadoop Definitive Guide, Mahout in Action, and Hadoop in Action. So as you can see, the algorithm then finds there are two keywords, that is Hadoop and Mahout, in the items brought by Amaya. It scans the entire item inventory and it recommends Amaya the item Hadoop and Mahout, as the two keywords Hadoop and Mahout are present in that item. So that is an example of item based recommender. So this was basically what difference between user based and item based recommenders. We'll see a short demo on the recommender systems shortly. So clustering, as we can so is as we know, is a form of unsupervised learning in which we group similar objects together. Objects which are similar to each other are in the same cluster, while objects which are not similar to each other are in different clusters. Various decision measures like Manhattan and Euclidean are used to determine the closeness of the objects which are present in the data set. And third is classification, example of supervised learning. You train your algorithm based on a data set, and then whenever an unknown instance is provided to the algorithm, it classifies that instance into one, two, or more than two classes. So there are all the common implementations of classification algorithms are present in Mahout, like naive Bayes, decision forest, linear regression, and so on. Then Mahout also supports frequent pattern mining. The most classic example of it is the a priori algorithm. That is, the algorithm finds the items which are frequently appear together. So, for example, if we find milk, bread, and cheese are sold frequently together, we should place those items on the same rack so that the customer buys them together and the sales of those products is boosted. So, Mahout also supports this frequent mining, pattern mining. Now we'll discuss the k-mean clustering and how MapReduce is incorporated in the k-means clustering in Mahout. Before that, we'll see a sample word count example of MapReduce framework. As we can see, the input is in the form of lines. So first, the input is split into key value pairs, where the key is the offset of the line in the file and the value is the entire line. So this is the splitting phase. Then the mapping phase converts this key value into intermediate key values. That is, whenever a particular word occurs in a file, it is set the value for that particular word is set to 1. As for example, in the first line, deer 1, bear 1, and river 1. Next phase is shuffling. Shuffling brings all the similarly occurred words in the mapping phase together. For example, we can see bear has occurred two times in line 1 and line 3. What shuffling does is brings both of these occurrences together. What reducing is done, that is, it sums all the occurrences for a particular word. That is, bear 1 comma 1 now becomes bear 2, and the final result is that this reducing is done for all the words, all the distinct words in the file, and the word count for those particular words is shown finally. So this is a sample MapReduce word count example. So in the k-means algorithm, as we know, the normal k-means algorithm is pretty simple. Initial cluster centroids are chosen, then points are assigned to a particular centroid, which denotes a particular cluster based on distance measure like Euclidean, Manhattan. Then the centroid is recalculated, and again the points are associated to the centroids based on the distance measure. This is done iteratively until the output of two successive steps is same. So this is the basic k-means algorithms. What k-means, how the k-means works in MapReduce is what's interesting. So here we have a data set which is large points. We have a large amount data set here, that is could be lakhs or crores of points. Initial centroids are chosen. So in map, what mapper does is that each map reads the k centroids plus one block from the data set. That is, points are divided into data set, and then this data points are divided into blocks, and each block is then sent to mapper. So the output of the mapper is centroid and point, that is, it associates each point with a particular centroid. The reducer gets all the points for a given centroids. That is, it brings together all the points for suppose the centroid is k1, it brings together all the points which are associated with the centroid k1, and it then recomputes the new centroid. That is, logic for recomputing the new centroid is present on the reducer, and the output is the new value of the centroid in the reducer. So this is how k-means takes place in the MapReduce framework. Now we'll also see an recommendation system demo in this screencast. So this just lists out the interfaces that Mahout has for recommendation systems. We'll see what this interfaces are in the demo. We'll see in detail what these interfaces are in our demo. So this is the code for an small or a very simple user-based recommender system, which is done using the libraries which are provided by Mahout. So as mentioned at the start of the screencast, that Mahout can run on Hadoop and also without Hadoop. So this is a standalone version of Mahout, in which we just use the Mahout libraries to form a simple user-based recommender system. So the data that we are going to so the aim of this demo is that we are going to recommend an item to a particular user based on the purchase history of that particular user and the rating that he has given to that particular item, also considering the other users who have purchased the items and the ratings that they have given to that item. So that the data that we are going to use for this demo is this. So this data basically contains three fields. The field 1 is the user ID, the field 2 is the item ID, and the field 3 is the rating that the user has given to that particular item. So even in the real world, the data that you will use is going to be in the form of numeric. Although this numeric fields might be mapped to some actual value. For example, user ID 1 might be mapped to a particular username. Item ID 101 might be mapped to a particular item but whenever you train or whenever you supply the data to the algorithm, it will be in the form of numeric form. So I'll repeat again: the field 1 is the user ID, field 2 is the item ID, and field 3 is the rating that the user has given to the item. The aim of this demo is that finally we'll recommend an item to the user 1 that he should buy. So that is a user based recommendation system. The algorithm will base this item on the rating that user or the items that the user 1 has purchased, and also the items that the other users, that is 2, 3, 4 and 5, have purchased. So this is the code for it. You have to, before you can perform this code, you have to import the jars, specific jars. You have to add those jars to a build path. This is an example which is given in the official Apache Mahout website. The jars which you will have to import are also given there. So these are the various packages that we have imported, which are needed for our for our demo. So basically, Mahout has four main interfaces that we need to take into account. The first is the data model. So data model provides a way to bring the data into the form that Mahout understands. So we have to read this sample.txt file, that is our data, and that is done using the data model object DM. Next is user similarity. That is, whenever you want to find a similarity between the two users or between two items purchased from the user, you need a similarity measure. So the user similarity class provides various similarity measures. We'll use the Pearson correlation similarity measure in our code. Then next is the neighborhood object, which is of the class user neighborhood. So it is like the n neighborhood concept, where you have to determine how many similar users that you want to finally recommend. So that we take the neighborhood. For that we need the neighborhood object. And finally is the recommender object, which encapsulates all the three fields that we have seen above. That is the neighborhood, the data model, and also the similarity measure that we want. So these three fields are passed to the recommender object, which is we can say our driver object, that is which actually performs the recommendation system. Finally, there is a list in which we actually store the recommended object for a particular user. This 1 comma 1 here denotes that you will recommend one item to the user with ID 1. So finally what we will get, based on the purchase history of all the users and also purchase history of all the users and also the ratings that they have given to the items, we'll recommend an item for user 1. We'll recommend an item for user 1. And finally we print that recommended item. So when we run this, you'll see now. Yeah. So as we can see, in the output we get the recommended item. The item is 104, value 4.257. That is, it recommends an item 104 with a preference rating of 4.257 for the user with user ID 1. So this was just a small example with a very small data set in a standalone version of Apache Mahout. So I hope that you enjoyed this screencast and understood the basic concepts of Apache Mahout. All the documentation regarding Mahout is available on the official Apache Mahout website. Thanks for watching this screencast.